The career pursuit, interviews, whatever. I know we talked to ask about that one yet. Okay, so maybe the level 2 failed the level 3 exam so that they have to get pretty good. But it's a 60-day period. I looked into it. It's a 60-day period, so at least you'll enjoy your summer break. It's the last one you get before you're in full time. All right. Any other updates? Give you some. No. Where do you go?
I took the exam for city of Compton
Cool.
on Tuesday. And it was pretty easy to exam. The only thing I struggled with was just like concrete. I mean, public works doesn't make sense.
Yeah, and then knowing that such a broad array of what they do, that if you show obviously a good affinity for one thing, they can help you on the back end.
Yeah.
Do they have some kind of concrete classes in school? Yeah. Oh, okay.
Yeah, construction and all.
Yeah, you can't know it all, but at the very least for the ones that you touted on your resume or in your interview, hopefully you delivered on that, and they'll be able to help you on the back end with other stuff. For those of you, how did you get get to that spot where you did testing for it? What was the application process like?
Well, just the application online was for electrical assistant. I passed. I got like an 89%. So I'm waiting on the date for the interview.
Yeah.
So hopefully they reach out to me soon. I'll be ready.
Very cool. Very cool. Yeah. All right. Yeah. Thank you for sharing. Keep us updated. This is cool because in previous classes, this is really starting off, we didn't get a chance to do a little, career update corner. I think it was going to be a staple of the class at this rate. But very cool. Yeah. Good on you. And thanks for sharing. And hopefully more news to come. So next set of slides we're going to be looking at here. Talk a little bit more about some of the insulating materials that we've looked at so far. There's not much nameplate information available on that kind of short run, but for those other long runs of cable, your go-to information again as the electrical test technician, you have to know what the cable is rated for you, so you can stress it to a meaningful degree, right? We've seen those handheld measures that only go up to 1 kV. Do we think that's going to cut it? Well, not quite, because you're not getting any valuable information. Remember the familiar industry expression is garbage in, garbage out. If you have a little Harbor Freight meter to test this guy, you go to the customer, you're looking all stoked, you're like, the test numbers, they look great with my Harbor Freight meter. Well, for something like this, you might give you a weird look and say, all right, next contractor on the list. So, yeah. So in this case, again, know the equipment you're testing, because that's going to dictate, your test parameters, your test KV, for example. And hopefully, as you pass these around, you're already recognizing the points at which you're going to connect the leads. And we're going to do this. So insulated material should have high insulation resistance, right? Megone, just like our familiar Megger brand Megger, right? High dielectric strength, right? And so dielectric strength we talked about our high pop, which is a dielectric withstand test. But again, if there is one single takeaway from this class, it is do not DC high pot service age cable, and that's it. You get any of this class. Well, that's not true, but if you walk away with one thing seriously, and you got into the industry, and if you kind of echo back to them, do not DC high pot surface age cable, they're going to know that you know what you're talking about, because that is one of the hottest industry monikers these days. Right. Good mechanical strength, right? Take a look at the example armor cladding you've seen in the pictures, right? High moisture resistance, especially if that is the type of insulation. Keep in mind, some of these might be conduit run, but if those conduits fill up with water, then so water installation one way or another. And withstand temperature rise. Familiar analogy would be your 310/15B2A, if I'm not mistaken, which would be your compensation factors for like elevated roof riser in your NEC, right? To account for the undue heat that your conductors may face, right? Because that's going to derate the allowable impact. So some kind of deal there. For number one, rubber cables are EPR, ethylene propylene rubber, which is a lot of the cabling. Yeah, EPR. So this is ethylene propylene rubber, for example. We'll see this is white EPR trademark, or the TM sign. White EPR, black EPR, brown EPR. That's another one. They're just various additives that, again, in one way may just come down to trade term, copyright issues, etc. Not that one highly outperforms the other. That's the world we live in. PE, our polyethylene, we did see that PE as well as our PVC, for example, the outer jacket. Polymer cables, and this would be our PVC polyvinyl chloride, which we've seen in NEC as well. XLPE, cross-linked polyethylene, which I think we had an example of that going around. Number 3, paper cables. We talked about the oil impregnated paper. Paper alone is not a good insulator, but they found the magic in the secret sauce. The Krabby Patty formula, when you combine your paper with oil and you use various impregnation processes, like under vacuum, for example, you get a consistent kind of distribution. It becomes an excellent insulator. And actually, we already have the teaser for the 268 transformer class. We see a lot of paper insulation in some of our transformer systems. Service age cable.
Service what?
Service age cable. Now, what is service age? Yeah. I'm gonna write it down. That's how important it is. Yeah. And so the expression I used was, hey, you take your new car, drive it off the lot, you're like, now you're getting cold feet, you return it back to there, I'll give you half. What? Take you full price for the car. Yeah. So you energize that cable. If the customer may very well call it service age because it's not, factory proven or whatever right off the conveyor belt. At some point, that 220 kV cable, for example, if that's ever seen 220 kV and they try to get it back to you, are you going to consider that new cable? So, and the point of the service age cable was over time, it's going to develop these natural voids, natural deterioration over time, right? And these little voids are the ones that conduct charges, right? And eventually will bridge the gap from your conductor to the outside world, and then kaboom. So, because the DC high pot is going to continuously build up space charge, eat away at that material, and it's going to accelerate basically cut into the life expectancy of the cable. It'll accelerate failure. So that's what they found through extensive research. So that's why we need DC high pot service. Good question. Vulcanized rubber insulations. Rubber is used in cables with rated voltage, 600 volts to 300 kV, like some of the examples you've seen. The two main groups would be our general purpose as well as our special purpose. 4 main types will be our butyl rubber, silicone rubber, neoprene rubber, and our styrofoam types there. And again, if nothing else, have this as reference material to get to 100% on your quiz when the time comes. So for polymer, again, our PVC, rated voltage 3.3. Different grades of PVC. We're seeing general purpose type, hard grade type, or heat resistant type, depending on the insulation that you're going to go with. And polyethylene, XLPE rated voltage up to 275 kV. Paper has little insulation value alone. However, when impregnated with a high grade of mineral oil, it serves as satisfactory insulation for extremely high voltage cables. The oil has a high dielectric strength, tends to prevent breakdown of the paper insulation. Paper must be thoroughly saturated with the oil. Thin paper tape is wrapped in many layers around the conductors and then soaked with oil. So one thing that's nice about paper insulation is that it's not subject to these same types of issues you're going to see with DC high potting. So you can actually, not that anybody really specifically requests it, but if you wanted a high pot paper insulated cable, that's actually fine because you don't have these same voids as part of your extruded cable. So the term extruded comes from the process where you just kind of push this different material throughout. You're going to have these space charges, and those are going to be eating away your material, but it doesn't happen with paper.
Is it the same oil you use in the circuit breakers, in the high voltage? High voltage circuit breakers, is it the same oil or is it different oil?
It could be the same oil. Mineral oil, very common. Although, especially in California, FR3 is like a biodegradable oil. Because obviously with oil spills and stuff, it's a sort of environmental concern. Just insulating mineral oil. Shell products, the gas company, they have a whole, petrochemical division based on like mineral oil, which is called the Diala series. But that is one of the common insulating oils that we deal with on the regular. But there's also FR3, Astarol oil, ASTAREL. A whole bunch of different types, and again, if nothing else, copyright issues. But yeah, these are made to perform to very, very high AV values. So depending on your application and how much the customer is willing to spend, by all means. Yeah, great question. Cool. All right, so let's talk about, because Jeff asked about the underground cables, let's turn it on its head, look at the other side of that coin for overhead lines. The insulation cost is more in case of cables as compared to overhead transmission lines, OHT, and depends on the operating voltage of the cable, right? And so here's just a correlation between your KV 0.4 and 1132 KV 66. There's a 220, like the example we saw in the previous set of slides, to our cost ratio, right? So the erection cost of the overhead transmission lines is much less than the underground cables, right? So to dig up trenches, right, to lay your cable and to bury them, etc. So the consideration when compared to running overhead lines. Inductive reactance of OHT lines is more, so the voltage regulation is better in case of underground cables, so low voltage drop. And what this means, inductive reactance, and you'll see, for example, the transmission lines, the type of spacing that those have, so that the inductive reactance doesn't, negatively affect each other, whereas that's kind of impeded by the underground nature of the insulation. So another consideration when speccing out overhead lines versus underground cables. Number 4, capacitance and charging current is high in the case of underground cables. Hopefully we're familiar with these equations here. So capacitance, right, or when solving for your inductive capacitive reactance, X sub C equals 1 over lowercase omega C, that's 2 pi F. Hopefully we all know that. I think we're good with our voting, right? Don't forget to vote. So in our case, at the 60 hertz in this great country we live in, right? So you might see this abbreviated as your lowercase omega, that's your 2 pi F. Right? Your charging current is equal to I sub C for charging is equal to V voltage over XC. This should look familiar because I equals V over XC is just the derivative of what? Whose law? This guy. Right? Because we know. Yeah, Mr. Ohm himself. R, everybody knows that R is also in AC circuits is a combination of your inductive and capacitive reactance. You may see all this, also see the Z for impedance and 3-phase, which is the square root of R squared plus XC minus XL. Okay, maybe that's with you, maybe not. But it's not going to be the quiz. It's a good news for you. For long distance power transmission, the charging current is very high, results in overvoltage problems. Not recommended to transfer power for a long distance using underground cables. And that's why you'll see the transmission lines all along, say, PCH or now when you make that scenic route. Current carrying capacity is more in case of overhead transmission lines, conductors, because of better cooling conditions. Anybody want to take a guess why that is? The moon for cooling? Yeah, like that. Especially the Artemis too. Clearly you were on the edge of your seat like I was. Yeah, so basically what would be the different heating kind of implications for underground cable versus overhead transmission?
Well, the underground, since it tends to be more moist, it's like a cooling factor, I guess, acting like a car.
Could be.
It keeps the current cool as opposed to air. And like you said earlier, the past classes, there's really no air circuit breakers because the current still keeps on pulling through.
Yeah, that could be consideration. So if it had rained, for example, yeah, I could cool it down. But that same kind of system that keeps heat out for a while could eventually keep heat trapped in. That's another consideration. But for the overhead transmission lines, when you're getting wind, and all that's actually good for cooling. Right?
What about like stuff in the desert? All their stuff is run deep underground or just?
Yeah, so if you've been in the desert at night, it can actually get pretty cold. So don't underestimate that one. But yeah, underground insulation could make sense for that. Another important consideration is wildlife, of course, in California, right? Think about who, bird protection is actually a big deal in some of these, especially anybody from the OC, they have like bird protection acts and stuff. And think about that. Think about like forestry, obviously with the fires that we've seen in recent years. Think about, and talking about wind, sure it's cooling as well, but actual movement of the transmission lines could cause some like very important issues. But basically, there are a lot. Al was added that there are many considerations when thinking overhead lines versus underground installations. So underground cables give greater safety, right? So that's an important consideration. Anybody see that familiar sign that says call 811? Yeah, call before you get it. Yeah, right there. So big cities and densely populated areas, submarine crossing, power stations, substations, and airports. And you don't want overhead lines.
Those an accident over White Lake Airport.
And that's one of the smaller municipal airports. And so what would happen? Yeah, so airports. There we have it.
Yes.
Okay, yeah, so definitely safety being the ultimate consideration. For cable application, yeah, transmission and distribution cables, XLPE cables, cables. For submarine cables, so it's another way of saying underwater, right? Rubber cables, industrial cables, PVC up to 3.3 kV, and your XLPE up to 11 kV. For those of you familiar with some of our, we took you through the NEC cables that are THHN, HW, or Dash 2, for example. Thermoplastic, heat resistant, water, W for moisture resistant.
Do they still use asbestos? Is that
Ideally not, but we do say it because it's out there.
You might
And so
write
it's
it.
the classic, you or loved one must have feeling.
That's what I was.
Yeah, so, but it's better that we know it's out there, because anybody, by getting people out into the workforce without this prior knowledge, they'll be like, I never heard of this. No, don't do that.
What does S stand for in the letters with the regulator?
S, letter S?
Yeah.
I'm not sure. Do you see a lot of those?
Yeah.
Well, maybe in your line of work,
Yeah.
in dredging, submarine.
SWOC and then,
Yeah, it could be submarine, water application.
I don't know what it means.
I'll look into that, but just because I know that you and your line of work kind of, my first guess would be submarine, especially dredging out there. These are obviously the NEC specifically states what do they and do they not cover. Any kind of maritime application. NEC specifically says, and it's not a. So it makes sense when NEC would outline it, but not have stuff that you've probably seen on the right. All right, cool. Yeah, so good examples for you there. More wire type identifiers. T for dry locations. W, would indicate wet applications is fine. Dry, high temperature. If you see HH, then it's high heat. So that would automatically put you in the 75-degree termination. Or actually, no, the 90-degree column in our NEC, HWTWN. And so if you apply some of the letters we'd see in this one, then you'll be able to piece together the application. So you're going to see these on the outside of the cable if they're still floating around. Every time you look at these nameplates and more, we call it a nameplate, but that's just kind of a generic term, even though it's not like a transformer nameplate or anything that's like literally a metal, fabricated metal thing. We still call it nameplate information even if it's stamped on the cable. Keep that in mind. You have direct burial in soil but not concrete. Yeah, so every time you take a look at a new run of cable, just try and pull out some of the pieces, practice identifying some of the properties of that cable, and especially because it'll help you become a better tester to understand some of these later tests. All right, so next up, a couple of notes on, let's get to all right, cool. So we have that wire shielded cable floating around. The one that we passed that one. Yeah, I'll take it. Hey, cool. Do I get exercise? All right, well, get the copper, one for that because it's aluminum. It's a lightweight. So, all right, well, plenty of options to clamp onto. I'll keep it like this. So in this case, we know that this operates up at very, very high voltages. You can see here, it says 15 kV. So I guess our font already took net. Okay, now that's going to be. Sometimes I'll talk about circuit breakers. So he's on to me. So now he's a little bit of sweet revenge. Right? It says insulating PE, now we know what this stands for, right? Polyethylene. Jacket, so the jacket itself is gonna be our polyethylene. Not much else we can see on there unless we have a longer run of cable, right? So in this case, what do we think about this guy here? Yeah, so this is like an insulating skirt, and I think it comes down to, each of these adds like 3 kV, something like that. Why is it sugar? Good question. Anybody want to take it?
When you touch it off the lug,
Okay, all right, yeah. In this case, what does it mean in terms of surface area? What would you guess? More or less surface area thanks to these skirts? A lot more, which means there is a lot more ground to cover if this guy wants to go off the path, right? So if we know that this is going to be your current carrying conductor and electricity taking the path of least resistance, now we've given it even more reasons to not go anywhere else than where it should be, which is right at the other end, making a product for it, right? And so what we're seeing is similar to the tape shield and similar to this drawing here, whereas in this case, yes. So instead of the tape shield, we've got this wire shield right all along. And so in this case, calculating for our resistance, for example, could be a little something like this. Right? So now we're checking for a good resistance of this material to any of the neutral shields that actually come together and tie together in this case. So as we're seeing, eventually, like the tape shield, you'll see examples of this, but at the end of each cable, you'll see that all of these individual strands actually tie together. They're all braided together. So by the time you clamp onto one of these, you're testing them all. So a fault anywhere in the cable, hopefully, ideally then, should be detected when you test it at the end of the cable. So let's do just that. So if this is 15 kV cable, somebody using their handy book, flip to the appropriate page and tell me
it's 5,000.
what the correct voltage is. Pretty good guess. Anybody back them up on that? Repeat that statement. Up for debate. We make all 5,000, which is good because this only goes up to 5,000. So I'm glad for that. Alright, so normally we run through our checks, we do our open test, closed test, and our known resistance to know that this is a good working instrument. Luckily we've done that plenty, and we are still due 9/16/25. Well, let's imagine that's 6 right there. Me and that Intellerent are going to have a little conversation. We're going to complain to the manager that the free stuff they sent us is no good. I don't have too much backing on that. Alright, so let me zoom out a little bit. So, all of you, the qualified experts, have told me that 5 kV is the move. So, I'm going to have this here. I will start by attaching this to our...
That's it, that's it.
Yeah.
Oh, okay, good save. Man, so, minus one, there goes your bonus point on the next.
5,000 mega.
So I hope you voted twice. All right, cool. So, and again, we've only seen examples of this, but this lug connection gets exactly onto the current parent connection at the point of determination, so we can get it where it needs to go. All right, so now we have our return. In this case, any connection on here, that would effectively look at all of the wire shield connections. So if the discharge, the unintended path goes to any of these, they should catch. It's the idea. So 2.5 kV. All right. We're going to test for 1 minute. Why do we test for 1 minute? Because it says. Okay, I like that answer. That's also correct. But again, we had Miguel's example of how the guy who ran that residential wire clearly didn't care about you because he said that's the next guy's problem, right? So you're the next guy. If I test it in 60 seconds, now we all have a standard we can agree on. So when Miguel comes in, he can also test in 60 seconds so that we're actually comparing apples to apples, right? Because if we know the insulation curve goes like this, unless we're all testing at the same point, how do you know it's not a lower reading because you didn't test long enough? Or how do you know, oh wow, the insulation quality went up over time, even though it's been getting beaten up and it's been 20 years, but somehow The insulation's better, is that possible? Well, I don't think so. So same deal, if you test it for 15, 20 minutes, well, it's just a natural curve. So we want something repeatable, we want something trendable, right? So me and Miguel, when we go into our various facilities, we're gonna do it 60 seconds. That way we have something to make good conclusions on. All right, so if my test setup looks pretty good, again, we're looking at the main current carrying conductor, which is why I'm on the lug, as well as the outside, right? Meaning we're looking at the bulk insulation here, this resistance. So not only does it look at this cross-sectional area, but for the entire run of the cable, however long this is, right? So if this fault is somewhere here, well, ideally we should be able to detect it because that's kind of your 3D representation. Okay? All right, so the setup looks pretty good. Test it. And again, we have the express, purpose to test. So hold it down until you see it's blinking. You have your visible indication, and you have the deep indication. So, what is our minimum expected resistance? 5,000. 5,000. Cool. So 5,000 megohms. If we were to convert that into gigohms here, right? We want to make the proper comparison. Because right now 300 is less than 500. Is this thing failing? No, not quite. Because we're not using the proper units, which again is why our metric prefixes are so important. All right. So even though 300 is less than 500, thumbs up, thumbs down. What are we looking at? Thumbs up. Pretty good because it's 300,000 megohms. Don't forget that. And 300,000 is definitely higher than 5,000. Or was it 500,000? All right, so we'll let that one run out. The suspense is telling. All right, cool. So what's our final value there? 351 gigahertz. Right? And then again, in comparison to our expected, which is in that right-hand column, thumbs up, thumbs down. Thumbs way up. I like it. All right, cool, good stuff. And yet knowing that. Knowing that, luckily, knowing the surface area and the material of this guy, electricity is very, very unlikely to want to take this path when it's got an easy road to finish. All right, let's take another example. We saw our wire shield. We are going to test our tape shield next. So let's imagine, let's see what the rating actually is. We have